Error analysis is very important in case of any experiment. We should know what is the error the experiment we had done in. So this is very simple practical. You have given all the formulas here. There are two different formulas. You have given Peter's formula and Bessel's formula, and here is your data. This is just sample data. You can get any data from your previous experiment. Now what you have to do, you have to take the mean of these readings. I have taken 7 readings. It may be 5 or 6, anything, a minimum 5 readings you have to take. Then take the mean of that readings, and again we have to find out z, which is nothing but this reading minus mean. Do this for all the readings. Sometimes you will get positive quantity, sometimes you will get negative quantity, and take the mod and then square it. Using this formula, you can find out the probable error by Peter's formula and probable error by Bessel's formula. Here n is the number of observations. In this case it is 7. Here you can see, first you have to take the summation of z square. You can also write here summation of mod zi and zi square. You can write the summation here so that you can put directly into this formula. Here the square root is applied for the term in square bracket, which is summation of zi square divided by under root n into n minus 1. Then you have to do another experiment, Cater's pendulum. I am providing you the link to do the simulation. We have to find out the acceleration due to gravity using this Cater's pendulum. Here you can see there are two different masses, m1 and m2, and two knife edges k1 and k2. So what we are going to do is we are hanging this pendulum first at k1 and then at k2. We will invert the pendulum so that m1 goes below and m2 goes up. We have to measure the time of oscillation, and using this formula we can find out the acceleration due to gravity, where L is the distance between two knife edges k1 and k2. T1 is time of oscillation first case, and then when we invert the Cater's pendulum, then we will measure T2. Observe the length between two knife edges. In this observation table, you are finding here T1, T2, and here there is capital T1, capital T2. So what is the difference? As we cannot measure a single oscillation, we will measure number of oscillation, let's say n oscillation. So for n oscillation it may be 10, 20 or 50. Then divide that number of oscillation to get time period of single oscillation. So this will be T1 and T2. You can take 3 different readings and take the mean of these two and put that into the formula to get the acceleration due to gravity. So now we will go to the simulation. Here is simulation by Willingdon. Here you can adjust the mass of the steel cylinder and wooden cylinder, but we don't need to do that. You can keep this as it is. You can change the position of knife edges, and accordingly the distances will be changed. Here there is a knob of show measurement. You can click on that so that you can measure these distances. So what we have to measure? We have to measure the distance between this knife edge and this knife edge. So add these two numbers, you will get capital L in centimeter. Move the pendulum by clicking on that and start the timer when you are ready to count the oscillation. Take n number of oscillations and measure the time period for that. N can be 10, 20, 50, whatever. More the n, more the accuracy. So you can start here. 1, 2, 3, 4, 5, and so on. So whenever you are done with your number of oscillations, you can click on the stop button. You note the time period. You have to do it 3 times, and after doing this you can reset this timer with this knob. You can stop this pendulum and then invert or reverse. you will get the option of invert or reverse. You will see the cylinders are exchanged, and now again you can measure the time period for the same number of oscillations as you recorded for the earlier case, and then you will get T1 and T2. And then if you want to change this length, you can reset this and you can change it again from this side. Choose a length such that the time periods are nearly close to each other.